RBC size. Now, there are three types of anisocytosis. The first one would be your normocyte. Now, your normocyte class, this would refer to your normal RBC. Normal RBC. So, it would appear discoid in shape. Thus, they are often called discocyte. Now, ulitin ko, your normocyte class, this would refer to the normal size of your RBC. They would be often appear discoid in shape. And thus, they are called also as discocytes. The normal size, this is the normal size of your RBC, is 6 to 8 micrometer. It is enucleated without nucleus. And your RBC class has a 120-day lifespan. So imagine once your RBC becomes mature RBC, they now have 120 days. 120 days to live in the peripheral blood. Now, the small size is similar to your small lymphocytes. So whenever you're going to be asked, what size would you compare your RBC? It would be similar to a small lymphocyte. Okay. Now, another type of anisocyte. So this is classified the appearance of your anisocytes, or your normocyte rather. They would appear as a common RBC with a central pallor. Central pallor that occupies 1/3 of the cell. Again, your normocyte has a central pallor that occupies 1/3 of the cell. So this is your central pallor. Now, another type of anisocyte would be your macrocyte. Now, macro meaning big or large, and cyte meaning cell. So this would refer to your large cell, specifically your larger red blood cell. Now, remember the normal size of your RBC is 6 to 8 micrometer. Now, if it goes beyond 8 micrometers, if it is greater than 8 micrometers, it would be known as your macrocyte. And it also has an MCV, mean cell volume, greater than 100. Just remember, class, your MCV would refer to the appearance of your cell volume, meaning the size. An MCV of greater than 100. Now, this is often caused by impaired DNA synthesis. Now, whenever, class, there are problems with the DNA material of your RBC when they are young, that could lead to your macrocyte. Again, macrocyte can come from impaired DNA synthesis, wherein when the red cell are still young, where they are still a reticulocyte, there could be problems in the DNA synthesis, and that would lead to your large RBC or macrocyte. Another one would be stress erythropoiesis. Now, when you say stress erythropoiesis, class, your bone marrow constantly produces RBCs. Class, I have a question. When would that happen? Kailan nangyayari na yung bone marrow mo would constantly produce RBCs? Can you give me a condition or a disease wherein the bone marrow would constantly produce red blood cells? Any ideas? Polycythemia, yes, but I'm talking about erythropoiesis. Polycythemia includes all your cells here, RBC, WBC. Now, what kind of disease or event that could cause your stress erythropoiesis? Okay, anemia is one, good. Now, remember class, when you have anemia, you would have decreased RBC, decreased hemoglobin. So to compensate, the body would produce more RBCs. Another one, give me another one, no? Polycythemia vera, yes, as well. That's possible. Hypoxia, yes, okay. What else aside from hypoxia? Yes, anemia. Any type of anemia could cause erythropoiesis. Um, Give me something class na pwede niyong ma-encounter on a daily basis that could lead to erythropoiesis. Starts with the letter T. No, it's a thalassemia rin. No, it's a tachycardia. No, hindi tumor. Hindi ka man, hula lang. Keep trying. Second letter is R. Okay. So we have what you call trauma. When I say trauma class, this could refer to injury or bleeding. So when you get trauma, injured or bleeding ka, you would have decreased RBC. And again, to compensate, the body would constantly produce RBCs. Now, while they are producing RBCs class, nagmamadali, they are constantly producing, there would tend to have defects. And within those defects would be your macrocyte. Remember class, pag nagmamadili ang production ng mga cells nyo, specifically they are being compensated too fast, defects could have problems. And another one would be your excess surface membrane. So in excess surface membrane class, imagine this would be your RBC. Now in excess surface membrane, the surface membrane would be enlarged. And this can be caused by a variety of drugs and disorders. And another one, you could actually see class macrocyte in pernicious anemia. So in pernicious anemia class, kindly write this down. This is caused by vitamin B12 deficiency. Class, can you tell me the other name of vitamin B12? What's the other name for your vitamin B12? What is the other name of your vitamin B12? Alright, very good. It's your cobalamin. So your cobalamin class, how would you get vitamin B12 class? Anong klaseng pagkain? What type of food? Any ideas on what type of food would be the main source of your vitamin B12 or cobalamin? Okay. What type of meat? What type of meat specifically? Okay. So we have what you call your red meat class. Now, in pernicious anemia, this is caused by vitamin B12 deficiency or cobalamin deficiency. Now, there are two ways on how you could get vitamin B12 deficiency. The one would be malabsorption. Malabsorption. When you say malabsorption class, your stomach, the stomach to isn't able to absorb absorb E vitamin B12. And another one would be your malnutrition. Class, may tanong ako. What type of people do not eat red meat? What type of people do not eat red meat? Anong tawag mo sa kanila? Hindi. Alright, you call them vegetarians. Now, they would often, pernicious anemia could often happen among vegetarians, specifically young vegetarians. Okay? Ulitin ko. Your pernicious anemia class is caused by vitamin B12 deficiency. Now, vitamin B12 deficiency, also known as cobalamin, could occur in two ways. Malabsorption, wherein the stomach isn't able to absorb the vitamin. Another one would be malnutrition. Hindi sila kumakain ng enough dietary products that contain vitamin B12, specifically red meat. Another one class would be your so-called aplastic anemia. Now, in aplastic anemia class, this is primarily characterized by Pancytopenia. Do you know, class, the meaning of the word Pancytopenia? Any ideas? So we have the word pinya, we have the word pan, and we have the word cyto. No, it's not huge cells. So this would be cell. What does pinya mean? Low or decrease. And what does the word pan mean? All cells are low. Now, when all cells are low class, what are the cells that are being included here? What are the three cells? RBC, WBC, and their platelets. So in Pancytopenia class, all your hematopoietic cells are decreased. This is usually caused by what class? Any idea? Kailan nagiging decrease ang lahat ng cells nyo? Saan kayo titingin, class, kapag ang buong cells nyo are, specifically hematopoietic cells, are decreased? You would look at the where. Starts with the letter S. You would look at no, not stem cells. Wala. Come on. Sige. You would look at, starts with second letter is O. You would look at the whenever there are decreased cells, or specifically in the production, may problem sa production, where would you look at? You would look at the source. And where are they often produced, itong cells na to? Saan na po produce sila? They are produced in your bone marrow. Thus, if they are decreased, what happened to your bone marrow, class? Your bone marrow is damaged or malfunctioning. Okay? So in this case, class, ang hemoglobin nyo would be less than 100 grams per dl. Kindly write this down. Then, yung WBC nyo, class, is less than 1.5 times 10 raised to the 9 per liter. And yung platelet count nyo is less than platelet count is less than 50 times 10 raised to the 9 per liter. Ulitin to, class. In aplastic anemia, we have what you call pancytopenia, wherein all cells are low or decreased. This include a decreased RBC, WBC, and platelet count. The reason for this, class, is your bone marrow is damaged or injured. I will discuss the specifics of that sa anemia nyo, class, in finals. Your aplastic anemia is characterized by hemoglobin less than 100 grams per dl, a WBC count less than 1.5 times 10 raised to the 9 per liter, a platelet count characterized by a less than 50 times 10 raised to the 9 per liter. Okay. Another one, class, would be your cirrhosis of the liver. So you may be wondering, what is the possible reason for inclusion of cirrhosis of the liver, class? Now, in your so-called cirrhosis, class, cirrhosis is a type of liver disease. And one of the places wherein your cobalamin or your vitamin B12 is stored or metabolized is the liver. So when your liver has cirrhosis, you cannot metabolize your vitamin B12, causing macrocytes. Again, your cirrhosis of the liver is a type of liver disease. Now remember, your liver is where vitamin B12 is stored or metabolized. And if the liver is damaged, it cannot be properly stored and metabolized, leading to decreased vitamin B12, causing your macrocytes. Intindihan? Any questions? Okay, proceed to the next slide. So this is the appearance of your macrocyte, class. So this would be your macrocyte. There is no central pallor. Wala na siyang central pallor, class. And And the last type of anisocyte class would be your microcyte. So your microcyte class, these are cells less than 6 micrometer in diameter. Class, ano ang MCV niyan? What's the MCV of microcytes? Okay, so it's less than 80 femtoliters. Now, these are small and round cell and can be due to fragmentation. So, naalala nyo class on how your RBCs die, one of those would be your fragmentation. Now, your microcyte can be the failure of hemoglobin synthesis. Hemoglobin synthesis. Okay, first one would be your iron deficiency anemia. Class, give me 3 possible ways on how you could get iron deficiency anemia. Okay, so we have your malnutrition. So, malnutrition. One more. Two more. So, ito related to sa, lack of food in iron in your diet. What else? Give me 2 more. A very good blood loss. And another one. Malnutrition, blood loss, and starts with the letter P. Okay, so we have your pregnancy. Miss Qualquera, bakit pregnancy? Why would your iron be decreased in pregnancy, Miss Qualquera? Why would your iron be decreased in pregnancy? Any ideas? So can help Miss Blanche K. Blanche. Why is your iron decreased in pregnancy? So what? Okay, so nag-share ng baby. So in pregnancy class, the mother circulation is being mixed with the baby. And the baby, you would consider this as a type of parasite. Not technically a bad parasite naman. Nagiging parasite lang siya, nagiging bad parasite lang siya class pag yung mother mo does not have a proper diet. So yung mga malnourished na mother, now that could lead to your iron deficiency anemia. Sa blood loss naman class, remember when you lose your blood, since iron can be found, ferrous iron can be found in your red blood cells, specifically the hemoglobin, that would cause iron deficiency. And malnutrition class, you could have iron deficiency in malnutrition if you do not take iron foods rich in iron. At least may idea kayo pag magsasagot kayo ng essay. Then another one would be your thalassemia class. So your thalassemia, hindi ko pa dapat ito discuss, but sige, ano ka na. Now, in thalassemia class, remember you have your globin chains. The globin chains class in thalassemia, globin chain production is decreased. And when your globin chain are decreased in production, they would not be able to bind the ferrous iron. They would not be able to bind the ferrous iron, leading to your microcytes. Again, ulitin ko, thalassemia class is characterized by decreased globin production. And when there is decreased globin production, your RBC would not be able to bind your ferrous iron, causing decreased iron. Then we have your so-called anemia of chronic disease. So in this case class, anemia of chronic disease class, this could include the following disorders. So you may be wondering, ano yung mga chronic disease, sir? So this could include your connective tissue disorders, um, malignancy, renal, thyroid, and pituitary disorders. Now, this type of diseases class are chronic. When you say chronic, matagal nang meron, for long term yung disease niya. Now, what happens would be there is a defective iron utilization in the body. This disorders class would cause defective iron utilization, leading to your microcytes. Again, anemia of chronic disease includes connective tissue disorders, malignancies, renal, thyroid, and pituitary disorders. These disorders will then cause defective utilization of iron. Hindi maayos magamit ng body yung iron ng maayos. Another one would be your lead poisoning class. Class, how would you get lead in your body? Any ideas? How would you get lead in your body? Any ideas? Okay, good. Another one reason is pain. Kala ko ingestion of paint. So you could get your paint if you're constantly exposed to it by inhalation. Ingestion of paint particles, yes, as well pwede. So usually class, your lead can be taken or gotten from exposure sa environment. So those would be your paint. Now, what lead does to the red blood cell is this. Your lead would inhibit heme synthesis. Inhibit heme synthesis. And when heme synthesis is inhibited, that would lead to your microcytes. Again, your lead poisoning can be gotten from exposure to environment, specifically via paint, inhalation, or ingestion, wherein lead would inhibit heme synthesis. Okay. The last one would be your sideroblastic anemia. So in sideroblastic anemia class, there is what you call accumulation. Naiipon sa Tagalog. Accumulation of iron in the cell. In the cell. It would appear as a ring, as a ring, as a ring in young RBCs. Imagine class, this would be your pronormoblast. So may makikita kang parang ring shape dyan. So that's one of the characteristic. Yung ring shape na yan, yan yung accumulated iron. And remember, when iron is again decreased, that would lead to your microcyte. Again, Cerebroplastic Anemia class is characterized by the accumulation of iron in the cell. It would appear as a ring in young RBC precursors. Now, one characteristic of microcyte class is that it has a larger central pallor. Mas malaki yung central pallor niya. And smaller in size. So that ends our Aniscytosis topic. Any questions? Naintindihan naman? Okay, so if there are no more questions, we will now proceed to your lesson 7. Your Poikilocytosis. Now, when you say Poikilocytosis class, this will refer to the variation in shape. So, first one would be your Discocyte. Your Discocyte class is the normal cell with a biconcave disc with increased surface to volume ratio. That is your Discocyte. Another one would be your target cell. Class, your target cell are also known as codocytes or platycytes. They would appear as a Mexican hat cell or cell with bull's-eye appearance. Parang ganito sila. This is the Mexican hat appearance class. This is the bull's-eye appearance. Para kang may target sa gitna. Now, this is an RBC with a distinct peripheral and central zone of hemoglobin. So this would be the central zone of hemoglobin niya. You notice yung normal RBC nyo may central pallor lang. But this time, instead of having a central pallor, it would have a central area of hemoglobin. And an annular area of pallor in between. Target cells result from cells having a surface which is disproportionately large compared with their volume. Mas malaki daw class yung size kesa sa laman. So in general terms class, imagine a 1.5 liter of Coke containing only 500 ml Coke. So that's happened. So the size of your target cell is very large, but it isn't fully containing hemoglobin. Results from having a surface which is disproportionately large with the volume. Now, they can be found in thalassemia. Remember, in thalassemia class, you have problems in your globin chain. And your globin chain would have effect on the structure of the cell, the RBC. Another one would be your obstructive and chronic liver disease, iron deficiency anemia, hemoglobinopathies, SS, CC, DD, EE, and after splenectomy. If you recall a class dun sa sickle cell niya, di ba? One of the characteristic cell that you can find will be your target cell. Any question for target cell? Okay, so this is their appearance, the Mexican hat, and they would appear as a target cell. May bullseye kayo sa gitna. Another one would be your so-called spheroidocyte. Spheroidocyte class are thicker than normal RBC. It is the intermediate between RBC and spirocyte. So when you say RBC, intermediate class, this is the stage before your RBC becomes a spirocyte. So RBC, it would look like this. RBC, spheroidocyte, and then spirocyte. So when you're going to be asked in your exam, what is the stage that comes before your spirocyte? It would be your spheroidocyte. It contains higher than normal concentration of RBC, of hemoglobin, and has a small area of pallor that is usually off center. Again, your spheroidocyte, this is the stage intermediate between RBC and spirocyte. It contains higher than normal concentration of hemoglobin. It has a small area of pallor that is usually off center. So the central pallor, it doesn't have a central pallor anymore. Pwedeng nandito siya sa bandang side. Then another one would be your elliptocyte. Your elliptocyte class is also known as your ovalocyte. Now, this is a narrow oval cell with a normal central pallor. Elliptocytosis can be found in healthy individuals. They are usually found in healthy people, but only in less than 10% of cells. They can also be seen in megaloblastic anemia, hypochromic anemias, and hereditary elliptocytosis. Now, your hereditary elliptocytosis class is an autosomal dominant disorder. Autosomal dominant disorder. So when you say autosomal dominant class, imagine if this is the father, then this is the mother. So if the father has elliptocytosis and the mother does not have, it would still get inherited by the son. So if only kahit isa lang yung meron, it can still be inherited. Compared to your recessive, kailangan dalawa yung meron. Again, your hereditary elliptocytosis is an autosomal dominant disorder wherein even if one parent has it, it can still get inherited by the child. By the child. The reason for this class is there is a weakened structural membrane of your RBC. Of your RBC. Your RBC. Due to caused by defective association of What composes your class? Your RBC membrane? Ano nagko-compose sa RBC membrane nyo? Sige, tingnan natin if naalala nyo. What composes your RBC membrane, class? Diba tatlo yun? Tatlo yung parts ng RBC membrane niya. So we're talking about the structural part, which is, that's the surface, Danny. I'm talking about the structural. So when you say structural, no, it's not your phospholipid, but it starts with the letter P as well. So it's your what? So tatlo yan. Among those would be your protein. So ulitin ko, class, ha? Your hereditary elliptocytosis is an autosomal dominant disorder caused by weakened structural membrane of your RBC due to defective association of proteins. This defective association of your proteins is known as horizontal effect. Horizontal effect. Autosomal dominant disorder, wherein even one parent has it, it can still manifest in their child. It is characterized by weakened structural membrane of your RBC due to defective association of protein known as the horizontal effect. Any more questions? Question ba, class? If none, I'll proceed to the next slide. So this is the appearance, class, of your elliptocyte. So they would appear oval in shape. May central pallor din. So if you're going to be asked sa exam nyo if your elliptocyte has a central pallor, it is yes. Okay, another one would be your biscuit cell. So biscuit cell, class, this is a type of folded RBC. So imagine this is your RBC. Imagine the other half being folded. Would now look like parang ganyan. This is found in hemoglobin C and hemoglobin SC disease. Hemoglobin C and hemoglobin SC disease. Class review. What is the usual partner of your hemoglobin C? Sa sakit. What type of hemoglobin? Hemoglobin C usually partners with your hemoglobin S, causing your hemoglobin S. So biscuit cell is a folded RBC found in hemoglobin C and hemoglobin SC disease. So this is their appearance, class. Pinupe. So parang ganyan. So from a normal shape, the other half would be folded, appearing like this. Any questions? Okay, another one, class, would be your bronze elliptocyte. So this time, class, this is a type of elliptocyte, class, that possess a bipolar or central distribution of hemoglobin and is typically seen in sickle cell anemia. And Brown's elliptocyte possess a bipolar or central distribution of hemoglobin. Usually, class, ito yung elliptocyte nyo. Then there would be a concentration of hemoglobin on both polarcytes. And this is typically seen in sickle cell anemia. Now, next one would be your sickle cell. So this is characterized by a crescent-shaped cell due to abnormal aggregation of your hemoglobin S. Tapos ano yung test na ginagamit for sickle cell? What was the test for your sickle cell? Naalala niyo pa? You still remember the tests used for your sickle cell? What is the test used for your sickle cell? Wala nang nakaalala? No, it's not your chromatography. Solubility test. So, anong reagent, Miss Calquera, nung solubility test mo? Saponin and what's the other one? Search with the letter D. Dithionate. Dithionite. Pati ako nalilito. Okay, so that would be the test for your sickle cell. Now again, your sickle cell would appear parang crescent moon siya. So, this is usually caused due to abnormal aggregation of hemoglobin S. They are also known as drepanocyte or meniscocyte, found in sickle cell anemia and sickle cell trait. Class, how would you write sickle cell trait? Paano niyo isusulat siya? How would you write sickle cell trait? HB ano? HB HBCG. Eh, pa-B antigen yun. Ano, Jo? HB. So, Miss Jacobo, which of those two is sickle cell trait? Sino si sickle cell trait mo dyan? Yung homozygous o yung heterozygous? Sickle cell trait class. Is it the homo or the heterozygous? So it's your homozygous, HBSS. Kapag sickle cell anemia class, heterozygous, HBAS. Bakit A? Remember, adult hemoglobin to ha? We're talking about your adult hemoglobin in sickle cell. And di ba nga hindi na de-detect ng solubility test niyo yung fetal hemoglobin? Naalala nyo. Common among Negroes. So this is the appearance of your sickle cell class. They would appear crescent shape. Okay, another one would be your Spherocytes class. Now, your Spherocytes class, these are microcytes, approximately 6 micrometer in diameter. More spherical than RBC. So, maliliit lang talaga sila class. Maliliit na bilog. They are characterized by a decreased surface to volume ratio and is usually caused from the genetic defect of the RBC membrane. They're often seen in hereditary spirocytosis, autoimmune hemolytic anemia. Plus, whenever you would talk about autoimmune hemolytic anemia, what does this involve? Ano ang umaatake sa red blood cells nyo dyan? What would attack your red blood cells causing hemolytic anemia? No, it's not the WBC. No, it's not the enzyme. It is related to your immunology and serology. What would attack? It's not the NK cells. All right, it's your antibodies. Now, your antibodies would see your RBC as foreign cells, thus attacking them, leading to your autoimmune hemolytic anemia. Ulitin ko, class, your autoimmune hemolytic anemia would be a autoimmune disorder wherein your own antibody would see your RBCs as foreign cells. And remember, foreign cells are always attacked by your antibody in your humoral immunity. And this, okay. Next, we have your ABO, incompatible hemolytic disease of the newborn. Plus, may idea kayo how does this happen? ABO, incompatible HDN, hemolytic disease of the newborn. Any ideas on how would this happen? Anong meron? We're talking about newborns. So, it is somehow related sa mother. Kailan nangyayari yan, Miss Rona? Remember, yung baby galing sa mother mo. So, dapat pareho sila ng di ba, ng blood type. So, when would that happen? Oo nga, not same yung blood type. Tama naman yung sagot niya. Kasi nga, di ba, ABO incompatible. But, any ideas on how would that happen? Very good, Miss Banyadera. So, if O, tapos iba ang blood type ng baby. Okay. Ganito yan, class. Meron tayong tinatawag na 4 types of blood type. A, B, maintindihan niyo. There are 4 types of blood type. You have your A, B, AB, and your O. Now, what I'm referring here as AG is antigen, or rather, yung nag-express, kaya sila naging A or naging B. Now, your antigen for your A would have your A antigen. And when you have your A antigen, you would have a B anti-B antibody. Bakit anti-B, sir? Di ba dapat pareho? No, hindi pwedeng pareho, class. Kasi kung anti-A antibody yan, aatakihin niya yung A antigen. And that would cause lysis. So, yung blood type B niya naman would have your B antigen. What's the antibody class of your B, blood type B? It would have what? Anti-A. Always include the word anti-A. Anti-A, antibody. How about your AB? Ano ang antigen ng AB niya? So, it's your A and B antigen. How about the antibody? Wala. Walang antibody. Walang antibody. Kasi kung merong anti-A or anti-B dyan, naatakihin niya to. How about your O? What's the antigen for your O? None. Wala. How about your antibody? would have anti-A and anti-B. Nag-blood bank na ako. Okay, now that you've identified the different antibodies class, your ABO incompatible HDN would happen if the mother is blood type O. And yung anak, yung newborn, would become anong blood type class? Tingin nyo. At blood type. At blood type. Sa tinanong ko, kakaturo ko lang sa inyo. What's the possible blood type for your newborn? Para mangyari yung ano, para atakihin ng ano. So, pwedeng blood type A, pwedeng blood type B, pwedeng blood type AB. Bakit? Your mother is blood type O. What antibodies does your mother have? Anong antibodies? If the mother is blood type O, what is the? So it would have anti-A and anti-B. Now, what antigens does your newborn have? So you have A, B, or AB. Depende sa blood type. So if let's say the newborn is blood type A, the anti-A would attack the antigen, the A antigen, causing your incompatible HDN. So class, tingnan nyo if your mother, ask nyo yung mother nyo if siya ay blood type O, tapos yung father nyo should be blood type B or blood type A. So be careful sa ganun ha. Kasi ABO incompatible HDN would happen. Naintindihan? Naintindihan ba? Sino nalito? May nalito? Ulitin ko if may nalito. Dali. I will teach you again kung nalilito kayo. We still have time naman. May nalito ba? Naintindihan kung bakit naging ganun? Yes, possible mangyari yon. We have what you call, saan ba ko pwede magsulat? We have what you call the Punnett square. So, yung Punnett square nyo, let's say yung father nyo is B, ang mother nyo is B din. Now, this can be either be heterozygous or homozygous. So, hindi mo masasabi yan, class. So, when you say heterozygous, class, it could be BO. Pag homozygous, BB. Same din yun sa father and mother, BB, BO, and BB. So, when you put that in a Punnett square, ganito, you can have BB, OO, BO, BB. So parang ganyan plus. I forgot how to do the proper Punnett square. But there is still a possibility to have a blood type O na anak. Kasi the blood type could be heterozygous or homozygous. And the only way to know this class if magpapa-genotypic testing kayo ng dugo. And madalas naman class ang blood type ng mga parents or ng tao would be heterozygous. Ako nga klase kami nga, ang mother ko is blood type O, ang father ko blood type B. Lahat kami blood type O. So there's a possibility. Okay? So your Spherocytes class would look like this. Very small, smaller than normal RBCs. Yun ang itsura nila. Okay, let's go now to your schistocytes. Now your schistocytes class, these are fragmented or greatly distorted RBCs. They may appear as helmet, triangular, or irregularly shaped. Now, this would happen when RBCs would lose fragments due to impact with fibrin strands, wall of disease, blood vessels, and artificial surfaces in the circulation. Class, can you give me a device, an artificial device that could be found, that could be inserted into your blood circulation? Specifically, the heart. Anong device yun? Okay, we have your so-called pacemaker. So your pacemaker class, ilalagay yan sa puso nyo kapag slow na yung heartbeat. Now, what happens is that your RBCs would hit the pacemaker, the surface of the pacemaker, and that would cause fragmentation or damage to the RBC. Ulitin ko, when there is a pacemaker or an artificial surface sa circulation nyo, your RBCs could hit them, causing your fragmentation or damage RBC, leading to your schistocytes. Now, there are two types of schistocytes, the helmet cell and the pycnocyte. Now, your helmet cells class would resemble a helmet seen in hemolytic anemias, while your pycnocyte would be distorted and contracted RBC, usually seen in infantile pycnocytosis and hemolytic anemia. Found in infantile pycnocytosis and hemolytic anemia. So this is your schistocyte. This one would be your helmet cell. This one would be your pycnocyte. Lapit na tayo matapos class. Okay. We now have your teardrop cell. This is also known as your Macrocycle. It resembles a teardrop and is a type of distorted or fragmented cell. This is often seen in myelofibrosis. In myelofibrosis class, the bone marrow is constantly producing abnormal RBCs. And one of those abnormal cells class is your teardrop cell. And we also have myeloid metaplasia. And this is the appearance of your teardrop cell. So mukha talaga siyang teardrop. Luha in Tagalog. They are seen in myelofibrosis and myeloid metaplasia. Next, we have your stomatocytes. Now, your stomatocytes are red cells in which the central biconcave area appears slit-like, as seen in a dried film. In a wet preparation, they appear as cup-shaped. This is primarily caused by primary membrane defect, alcoholism, or it could be also to a genetic factor present in blood smears of Australian of Mediterranean origin. Found in alcoholic cirrhosis, hereditary stomatocytosis, hepatobiliary disease, and the so-called RH null syndrome. RH null syndrome. Okay. They would appear like this class. Parang hulugan ng coins. Para silang hulugan ng coins. Stomatocytes. May slit-like. Slit. Ang Tagalog, hiwa or cut. The central part of the cell. Then another one would be your crescent bodies. So these are half-moon bodies or semilunar bodies of a chromocyte. Very large, very pale, large bodies usually located on thin parts of the blood smear. Usually caused by loss of hemoglobin as a result of mechanical injury. May be found in malaria or hemolytic diseases. So ito yung itsura nila. Poikilocytosis, another one would be your crenated cells. So these are red cells with numerous projections from their surface which are evenly distributed. Usually seen in washing RBCs in hypertonic solution. That's what happens to your RBC if it is put in a hypotonic solution. Ano nangyayari? They would, ano nangyayari sa RBC? Yes, they would lyse. Okay, they would swell. Okay, mag-swell sila, lolobo. But if they are put in a hypertonic solution, they would shrink. Mag-shrink sila, appearing crenated. Then you could also see them in uremia class. So in uremia class, this is caused by renal failure. Renal failure, wherein there is too much creatinine and too much BUN that are not excreted. Hindi na i-excrete. What happens class to creatinine and BUN kapag hindi sila na i-excrete? Saan sila napupunta? They will then go to where? No, they will now stay in the blood, leading to, when you say uremia class, this will be characterized by increased creatinine and BUN in the blood, causing crenation of red cells. Then we also have neonatal liver disease. Plus, anong itsura ng baby nyo, ng baby kapag merong liver disease? They are characterized by appearing as what? Anong tawag mo dyan sa yellow na yan? Very good, Mrs. Tolano. So they would appear jaundice. Jaundice. And when they appear jaundice, anong increase sa kanila na bilirubin? ba merong 2 types of bilirubin? Naturo na ba sa inyo yan, class? What is increase kapag jaundice kayo? What is increased if the newborn or the person is jaundice? Which type of bilirubin? Alam niyo ba yung dalawang klase ng bilirubin, class? Sure ka ba dyan, Weya? Sure ka ba dyan, Jo? Ako din eh. Joke. Ako rin, di rin ako sure, joke lang. So, pag jaundice kasi, class, it would usually relate sa blood nyo, so sa skin. So, most likely, it would be your B1 or your conjugated bilirubin accumulated. So, hindi ako 100% sure. I-ano nyo na lang pag tinuro sa inyo. And then another one would be your after exchange transfusion. After exchange transfusion. So these are the appearance class of your crenated RBCs. They would appear with spikes. Another one would be your echinocytes, also known as your sea urchin cells or your burr cells. Now, these are small cells or cell fragments bearing spines or spicules, or that are evenly distributed on the surface of the cell. They could be found in uremia, bleeding peptic ulcer, carcinoma of the stomach, pyruvate kinase deficiency. Plus, pyruvate, PK. Sa naaalala nyo sa mga pathways ng RBC metabolism, saan siya nakikita? Naalala nyo pa ba? Okay, very good, Ms. Silas. So, it's your Emden-Meyerhoff pathway. So, your pyruvate kinase deficiency class is the most common enzyme deficiency involving Emden-Meyerhoff pathway. It would result to mild to moderate non-spirocytic chronic hemolytic anemia with splenomegaly. So when you say splenomegaly, enlarge yung spleen. Ulitin ko, class, your pyruvate kinase deficiency is the most common enzyme deficiency involving your Emden-Meyerhoff pathway. It would result to a mild to moderate non-spirocytic. So that would be your echinocytes, chronic hemolytic anemia with splenomegaly. Then we also have renal transplant and post-splenectomy. Okay, so ito itsura nila, class. They would appear parang sea urchin. Burr cells, in other name. And another one would be your acanthocytes. Now, they are also known as your spur cells. They are RBC with spiny projections of various lengths and irregular spacing. Have 5 to 10 spicules. Abnormality is due to increased ratio of your cholesterol lectin on the RBC membrane. Increased ratio or cholesterol lectin on the RBC membrane ratio. Found in liver disease, hemolytic anemia, post-splenectomy, PK deficiency, and a beta lipoproteinemia. So, ito itsura nila, class. This is the appearance of your acanthocytes. Large yung spicules. Large yung spicules. So that and